Hi, welcome back. This is Professor Ridge. Today's lesson on section 7.2, rational numbers as exponents. So let's start off with the definition of what rational exponents mean. So if we have a to the 1 over n, that's the same thing as the nth root of a. When a is non-negative, n can be any natural number greater than 1. So if a is a positive number, there's no restriction on n. It could be any positive natural number greater than 1. If a is negative, so you can't do square root of negative 5 or fourth root of negative 8, so n has to be a odd integer. You can do cube root of negative 8, that's no problem. And then we can extend this definition to do any rational exponent. So this means the same thing as the nth root of a to the, or the nth root, oh no, I did it right, nth root of a to the m. So the top number is the power, and the bottom number is the index of the root. And it turns out you could do it either order. You could take a to the nth power and then the nth root, that's this one, or you can take the nth root first and then raise it to the nth power. Let's try some exercises from the book. Okay, so write an equivalent expression using radical notation and, if possible, simplify. So let's look at exercise 10. It says t to the 1/4. And from the first definition up there, remember that index is going to be the denominator of the rational exponent. So that's the fourth root of t. Number 12. 125 to the third power is the same thing as cube root of 125, which we know is 5 times 5 times 5, so that's 5. Number 14. 81 to the fourth power is the fourth root of 81, which is 3 times 3 times 3 times 3 is 81, so 3 to the fourth is 81, so the fourth root of 81 is 3. Okay, 100 to the 1/2 power, same thing as square root of 100, and then 100 is the same thing as 10 times 10, so 10 comes out. Okay, AB to the 1/4 in parentheses, so that's the whole thing that's under this radical sign, and remember the denominator is your index. Okay, 22, to the 3/2, that's the same thing as square root of a cubed, and again you can put that cube on the inside or the outside. Either way. And the index is 2, which is just the square root. When we don't write a number for the index, it's 2, square root. Alright, let's try number 24. 4 to the 7/2. Again, this is going to be square root of 4. Now if you're doing it by hand, it's better to do the square root first and then the power. Square root of 4 is 2. 2 to the 7th, so it's 2, 4, 8, 16, 32, 64, 128. Okay. Let's look at number 28. 125a in parentheses to the 2/3. So we're going to do square root of, no, cube root of 125a. Squared. So that's going to give me cube root of 125 times 125 times a, and 125 is, cube root of 125 is 5, so I got 5 times 5 times 5 So 2 5s come out, which is 25. Cube root of a squared. Let's go the other direction. We're going to write equivalent expression using exponential notation. So the big thing to remember is that the index is the denominator for the rational exponent. So 4th root of 10 is the same thing as 10 to the 1/4. Number 38. 5th root of n to the 4th, that's the same thing as n to the top number is the power, bottom number is the index. So n to the 4/5 power. Number 40, we got cube root of cb, which is the same thing as cb in parentheses, to the 1/3 power. 42, we got the 7th root of x cubed, y squared, z squared. Now remember that radical signs just like grouping symbols. So you got x cubed, y squared, z squared, and we're raising it 1/7 power. So you can leave it like that, which is all the book is asking you to do. And then you can use exponent rules and distribute the 1/7. So it'll be x to the 3/7, y to the 2/7, z to the 2/7. Okay, so that's probably the way I would write it. The book's having you leave it at the first step. Okay, it's just like the negative exponent rules. It works the same way for negative rational exponents. If you have a to the negative m over n, it's the same thing as 1 over a to the m over n power. So if we look at a couple of those exercises, like number 50, m to the negative 1/3 is the same thing as 1 over m to the 1/3, which is the cube root of m. 54, if we have 1 over 8 to the negative 2/3, now remember the negative part flips that fraction over. 1 over 8 is the same thing as 8. And then 2/3, we're going to do the cube root of 8 and then square it, so we're going to get 2 squared, which is 4. And that's your final answer for that one. So for 62, we have 7x over 8yz to the negative 3/5 power. Negative 3/5 power. So you get the negative flips it over, 8yz over 7x to the 3/5, and we'll just leave it like that. There's nothing else to do really. You can use exponent rules and distribute. And that brings us to our next point. All the exponent rules still hold for rational exponents. Okay, so let's just review all the exponent rules. If you multiply at the same base, now we're viewing m and n as fractions, rational expressions. So remember, you're going to add the exponents. So whether they're whole numbers or fractions, integers, whatever, it doesn't matter. You still use the same rules. If we divide with the same base, we're going to subtract the exponents. If we take a power to a power, we're going to multiply the exponents. If we do a product to a power, we're going to raise each of those to that power. A to the n, b to the n. If we have a quotient to a power, we're going to raise each thing to that power. Okay, so all those rules still apply, whether those exponents are whole numbers, fractions, doesn't matter. Okay, so the bases are the same, so we're going to add the exponents. So 1/8 plus 1/4 is, we write common denominators, so that'd be 2/8 plus 1/8 which will be 3/8, and that's your answer. If we do number 68, 8 to the 7/11 over 8 to the negative 2/11. So remember, if we're dividing, we're subtracting the exponent. So it's 7/11 minus 2/11, which equals plus 7/11 plus 2/11, which is 9/11. Okay, so it's no different. You know, it just might be a little uncomfortable for you at first. Let's look at 74. X to the 3/4 times x to the 1/3. So that's x to the 3/4 plus 1/3. Now in scratch work over here, let's see. 3/4 is the same thing as times by 3. So 9/12. 1/3 is the same thing as 4/12. 9/12 plus 4/12 is 13/12. And that's your solution there, or your simplified form. Alright, so sometimes simplifying radical expressions, we need to use this trick where it may not work using radical rules. So what we do is we convert it to exponential notation, and we use exponent rules. Okay, so you convert it to exponential notation, and then you use either exponent rules or just plain old arithmetic as necessary. And then you're going to convert it back to radical notation, if appropriate, or as needed. Okay, let's try a couple. So we're going to simplify these using radical notation, or exponential notation. So again, normally with radical notation, there's nothing you can do here. This is simplified. But we can say, all right, let's write this using exponential notation, and we notice that 3/12 can be reduced to 1/4. And so then we can convert that back to the 4th root of a, which simplifies using this different technique. So it turns out that the 12th root of a cubed, same thing as the 4th root of a. So if we look at 84, cube root, or 30th root of x to the 5th. So again, you know, if you notice, say 5 and 30, you can reduce that. So we convert it to exponential notation. We reduce the fraction. 5/30ths is the same thing as 1/6, and then we can rewrite it as a radical 6th root of x. All right, simple as that. Let's try number 92. We got the 6th root of the square root of n. And again, if we write it as exponential notation, we got the inside, we got n to the 1/2. Oops. To the 1/2. And then we're going to raise that to the, oh, I don't need that parenthesis. So inside we got n to the 1/2, and then we're going to raise that to the 1/6 power. And then we know a power to a power, you multiply the powers. So that's n to the 1/12. So the 6th root of the square root of n is the same thing as the 12th root of n. And if we look at 98, one more of these, we got the 5th root of the 3rd root, or cube root, 5th root of the cube root of 2a. So again, the 2a, this one I need parentheses, to the 1/3 power, and then that to the 1/5 power. So that's going to get us 2a to the 1/15th, which gives us the 15th root of 2a. Okay, so that completes section 7.2. Go to My Math Lab and complete your exercises there, and I'll see you next time.